Today's review is for PC6 about finding vertices. The first type of quadratic we look at is the one in Vertex Form. We can recognize this because it has one set of parentheses. To find the vertex for Vertex Form, we take the opposite of this number inside parentheses. So we see plus 4, we're going to make that a minus 4. And we take the exact number from the far right, the constant, which is a positive 7. And that's why they call it Vertex Form, because it's pretty easy to find the vertex anyway. Next up, we look at standard form. Typically, standard form has 0 sets of parentheses. That's one way to spot it. Our A value is -2, our B is 4, and our C is 6. We get these from these three numbers here, -2, 4, and 6. Make sure you bring the sign with them and call them A, B, and C. We use these in a formula because the x coordinate of our vertex is always going to be equal to -b over 2a. So x coordinate of the vertex is equal to -b divided by 2a. When we plug these numbers in, we get -4 divided by 2 times -2. The 4 was brought down, and the -2 was brought down. If we multiply this out, we get -4 divided by -4, which is just 1. And that's the x-coordinate of our vertex. We're halfway there. To find the y, we take our original equation, and instead of putting in x, like we had here, we're going to put in what x is equal to, which from our first bit of math, we found it was 1. -b over 2a, plug those numbers in, we got 1. That's what you plug in here. If this looks confusing, you can enter it in your calculator exactly like this, and you'll end up with 8. So your vertex is 1, 8. The next type of quadratic we'll look at is the intercept form, and you can recognize this because there are 2 sets of parentheses. To figure out m, we would take x plus 5 equal to 0 and solve it. But a faster way of doing that is just taking the opposite of this plus 5. So m is a -5, and n is the opposite of -1, so it's +1. We use our formula that m plus n divided by 2 equals the x-coordinate of the vertex. So when we plug in these values, -5 plus 1 divided by 2, we get -4 divided by 2, which is just -2. Again, this tells us the x-coordinate of our vertex, so we're going to plug it back into our original equation to find the y. And you can see here, everywhere there used to be an x, I've replaced it with a -2. You can add these together and multiply, or you can put it in the calculator exactly like this. Either way, when you're done, you'll get an answer of -9. So we can write our vertex as the coordinate -2, -9. In the next row here, things get a little bit more complicated, but the rules are the same. 2 sets of parentheses, we're looking at intercept form. M is 4, which is the opposite of -4. N is -2, because you take the inverse of +2. And we're going to use m plus n divided by 2. So if we plug those numbers in, we add them together, we divide, we get our x-coordinate, which is 1. We take our original equation, and wherever there was an x, we replace it with a 1. If we put this in the calculator exactly like this, we can find our answer, or you can use the order of operations. Either way, you'll get -27. So your vertex is 1, -27. Moving to the right, you might start thinking, oh no, fractions, this is hard. But don't worry, this is vertex form. You can recognize this because there's only one set of parentheses. So we're going to take the opposite and exact values from the set of parentheses and from the far right, the constant, and our vertex in one step will be 3, -11/4. Please get those right. On the far right, we see no sets of parentheses. That's a clue we're looking at standard form. First thing we'll do is identify a, b, and c. A is equal to 4, b is equal to -4, and c is equal to -7. We're going to use the formula -b divided by 2a. Remember that we're taking the negative of a negative number, so it turns out to be a +4 on top. And if we simplify this fraction 4/8, we get 1/2 for our x-coordinate. This is about that time where the parentheses come in handy. If we enter exactly like this on our calculator, with parentheses, we get the right answer. Without, order of operation goes wrong. We get -8 for y, so our vertex is 1/2, comma, -8. For this last function, the story problem, we don't see any sets of parentheses, so we can assume this is standard form. And we know that a is -2, that's our first coefficient. B is equal to 20, and our c value is actually equal to 0, because notice there's nothing added or subtracted at the end. So to figure out the highest height, we have to remember what the definition of a vertex is. The vertex is either the very maximum point of a parabola or the minimum point of a parabola. In this case, we're looking at something like this graph here on the left. So we're going to try to figure out what the vertex is, and that will tell us two things. The highest height will be the y-coordinate of the vertex, and we can also figure out how long it will be in the air. We start off with the same equation, -b divided by 2a. So -20 divided by 2 times -2, which is -20 divided by -4, which is a +5. So if we plug that into the calculator or resolve it using the order of operations, we get that y is equal to 50. That's our highest height. As far as how long it will be in the air, well, let's consider a coordinate grid. Because our c value is 0, we know that we are starting our parabola here at the origin. And we know that our vertex is at 5, 50. So this isn't perfectly to scale, but let's say that that point right there is 5, 50. That means our parabola is shaped like this. And we know that it's symmetric. So on the right, if we count over 5 more, that parabola is now heading down. So our vertex was 5. That was the halfway point. That was the highest the basketball shot got in the air. On its way down, it took another 5 units to get back to 0. So we can double that, 5 times 2, to get our answer, which is 10.